class. Here this chapter is the chapter number 11. Here I have already started solving some problem. One I already explained last video. Now I will continue from 2. I have already started, but as I am moving, I'll bit cautious taking the things so that everybody will be able to adopt, whether it is a whether it is a you can say the person who is not very fast in understanding or who is very fast and grasp the things easily. I'm just looking after everybody, and accordingly I'm formatting my classes. So be patient, so that you should not be lost somewhere. I'm trying hard to make it adaptable for everybody. So if I am wrong somewhere, if I am going fast or I am going too slow, I am giving very simple problem or a harder problem, let me know so that I can improve upon. But I am trying hard so that whatever I deliver, it can reach you easily. Okay, so let me continue. The second problem, it says a boy goes 2 meter west I'm just trying to deliver in a very traditional way. The way we have learned from our teachers is not that very advanced way of delivering something, so that it will be very much easier to correlate with our study. There may be possibilities that there may be advanced classes somewhere. You will get all such of advanced technology and presentation. My presentation may not be that much very upgraded one, but the way we have learned, I am just trying to, because that learning is very may be very common to the most of the persons who are having the facility to reach those technologies or those facilities. Okay, so I'm just trying to connect to all the students up to the lowest facilitate persons who are having their who are studying with very adverse conditions. Okay, so be with me, patience with me. If anything is there, kindly communicate so that I can improve, and I want to improve for you only. Okay, 2 meter west, then 3 meter north, and then 5 meter east. Find distance and displacement over whole journey, over whole journey. I think if you will try the theory that I have taught, it is very easy to solve. The first thing is that you have to understand the directions very well. You have to be very much acquainted with the directions orientation. Then it is very easy for you to solve. So these are the universal notation of directions: north, east, west, south. It also forms the news. So whatever you see the news, that is on the basis of the this directions, NEWS, and that's why it is very easy to remember. Okay. So now, as per the problem given, the boy goes 2 meter west. So if I move 2 meter to the scale, 2 meter this way to west. So he has started. This is his starting point. Let's say this A. moving up to B, as because he is moving towards west. So this is 2 meter. This is her, each segment is 1 meter. So this is 1 meter, this is 1 meter again. Then 3 meter north. So this is again he is moving north. This means 1. I equally want to bring. So let me get some space so that drawing can be completed. Let's say this is 1, 2, from A to B towards west. First west direction, then 1, 2, 3 north direction, reaching at C point. Then 5 meter east, 1, 2, 3, 4, 5, reaching at D. So these are the consecutive points: A to B, west, then to north, then to east. Okay, so this is west, north. So this is ultimate position. So now the thing, you will reach to D, and this AD will be the shortest if it is added straight path. Now if I draw vertical lines, so now this parallel to this, because west parallel to east, here the vector is this way, displacement vector. Now this is parallel to this. I am drawing a vertical which is parallel to this, which will mark at 90 degree to each other. So now if it is 2, what would be this mark? Now it has to be a 2 scale. So in this case this will be 2. Okay, so this must be 2 up to this. Now the next 3 times 1, 2, 3. Let's say this time extending bit this 3. So this will be D. So this part is 3 because total is 3. So now this is what? This is 3. This is 3, and again this is total 5. This is 2 means this is 3. So you have to find this for the displacement. D, AD would be the displacement, which is nothing but under root of this square, 3 square plus 3 square. This is 3, means if I name it some point E, so this is a right angle triangle because this is vertical to this. These are parallel lines. This is vertical, so this is 90 degree. So this will be how much? AE square plus ED square. So AE is how much? 3, because this is 3. BC is 3. So AE you can again replace with BC because these are parallel vectors, plus ED is nothing but what? CD minus CE. Okay, now if I write it here, so AD I will get equal to under root of BC equal to 3 square, and CD minus CE, CD minus CE, that means 5 minus 2 whole square. So ultimately it will give 3 square plus 3 square. So this is nothing but root 2 into 3. So that means we can write it like 3 root 2. So this will be the displacement. What is the distance? Distance nothing but, if you go on adding the distance following the path, so your distance actually is AB, distance equal to AB plus BC plus CD. So if you go on adding 2 plus 3 plus 5, which will give you 10. So it will be unit is all in meter. So this must be meter, this must be meter. So your displacement is 3 root 2 and distance is 10. Okay. Moving to the next problem. number 3. An athlete completes one round of a circular track, one round of a circular track of radius r in 40 seconds. Okay, what will be his displacement? What will be his displacement at the end of 2 minutes 20 seconds. Okay, so this is the problem given. An athlete completes one round of a circular path. That means he is moving following a circular path, circular track you can say. So its reference would be at center. Definitely it is a circular path. He completes a track of radius r. So radius is given as r in 40 seconds. So the distance that he covers, that means the complete rotation, it will be how much? 2 pi r. This is the distance is traveling. It is traveling when it is traveling in the circular path, and the time is taking is 40 seconds. This is unit is given, no unit is given, so this is in any unit. This will be in second. So this is the time taken. Fine. What will be his displacement at the end of 2 meter? So when it is, the first thing is that you have to understand, when it is moving in a circular path, there will be no displacement if it is coming back to the original position. Let's say it started with from A, and if it is rotates the full circle and coming back to A again, so there would not be any displacement. First thing is that. So only thing you have to, first impression should come in mind, if in this time he can return back to the actually to the original position, so then there will be no displacement. Now as the speed is given, the distance this much in this time, so how much he is going in this time, so that velocity is how much? 2 pi r by 40. This is velocity. So the total distance covered with the velocity v in time days will be v into t. So what is that? V already have 2 pi r by 40, and time, if I convert in seconds, 2 minute 20 seconds means 120 plus 20, 140. Okay, so this is cancelled out. So 227. So this is almost 3.2 of a complete circle. Okay, so that means up to 3 round he doesn't have any displacement. So only that 0.5 is the remaining displacement, that will actually can call it is a displacement. So the actual displacement is the final position to the initial position to the final position. what is that? This is 0.5 rotation, that means of 2 pi r. Okay, understood? So that means half of 2 pi r, that means from here he has moved diametrically opposite. Here half of 2 pi r, this is nothing but the full circle, and half of that it is the half circle. So he has moved diametrically opposite. So in that case, what is the displacement? Displacement is 2r only, because from this point he has moved diametrically opposite, and this is r plus r is equal to 2r. So this is this will be a displacement. Understood? Okay. Moving next. Number 4. A body is projected from a tower of height h, which reaches the maximum height h and return to the ground as shown in figure. I will show you the figure after this description. The distance and displacement of the body. So here I am just drawing it is the height h given. This is the tower, a project from a tower. This is the tower. From here it is projected as going to attaining a height of h and coming back and dropping it here. So now you have to find the displacement and the distance. Okay. So as you can see, there is a height of the tower is capital H, and the height by which the body is projected is raised height of small h. Okay. Now you have to calculate the distance and the displacement both. These you have to calculate. Okay. Now as you can understand that this tower height, although it is h, but the ball is projected from that height upwards. So for the first movement, if I take it as a linear movement, and this is divided into two parts, small h, capital H, there were two segments of the height. The first movement has moved this way. That is, if I consider the distance, the first, let's say this is upward motion is positive h, okay, and then after it has moved back to this tower parallel height, means in the same line of the tower. If we extend the roof of the tower, then it has moved the same height, because it will return back anyhow in the same line. So then again, if the upward direction is taken positive, the downward has to be negative. Then as there is no obstruction, it will fall freely through this capital height also. The total displacement from the start point and to the end point, here after striking to the floor, we are assuming that is not bounced back further and it has kept on rest. Once it is strike down, the velocity becomes 0 and it will be in rest. It is not again bouncing back. That we assume that, although it is not clear in the sum, but we are assuming, as the condition is not further being stretched, so we can assume that is a benefit of doubt, you can say, that assume that after dropping here it is in rest and it is not further lift any height and further it will bounce back again. So it is only one time motion. So it has started from here, gone to a maximum height, then coming back to on the floor. As it is, there is no restriction in between, so it will only be stationary when it will touch the ground. So that total displacement is, if it is upward is h, downward is minus h, and the further downward of the tower height is minus h. So here the ultimate displacement, although it is taken as negative because upward is I have taken as positive, so this is displacement. So the displacement will be the height of the tower. Don't take the minus sign, because it is only the significance of the displacement, means the direction. It is negative because displacement can be negative, positive or 0, anything that I have described earlier in the theory. So leaving the signature, only value is this one. Now talk about this is displacement. Okay, now talk about the distance covered. So distance, although it is not depending on the direction, so the actual distance it is moving, h there, 2h back means h again, and h capital H again. So the actual distance traversed is this one, whereas the displacement is this one. And this is also correct, because displacement is nothing but the distance, the shortest distance between the initial and the final position. And the initial position is the rooftop, tower top, and the final position the lying on ground. So the smallest distance must be this one. Okay, so from that aspect also the displacement is h and distance is 2h, small 2h and h. Okay, so this is for now. In the next video I will move on to 5 and onwards. Thank you.